Welcome to the channel. We're going over publicly available FRQs for AP Physics 1. This is a hilarious scenario where a boy is giving a ride to his dog on a sled. The boy is applying force of 55 newtons at the angle of 20 degrees to the horizontal. And there's a number of questions, A through E. A starting with the requirement of us to draw the free body diagram. So free body diagram will depict all the forces applied to the dog sled system as one dot. We're going to start with force of gravity. And you know how usually if something is just flat on the ground, we can say that force of gravity is going to be equal to and balanced by normal force. However, not in this case because the boy is applying a force that is not horizontal but has a vertical component. And because it has a vertical component, I'm going to draw it as such. Normal force is just visually, this is 3 boxes. AP board doesn't want you to show any components, so I'm just going to marking them to show you that it's 1 box. Then the remaining force that is still left for normal force would be 2 boxes, a little smaller than that. This is all just visual, so what they're looking for is you're marking the forces. You can do force of friction or you can just do FR. Remember, force of gravity cannot be marked as G or big G. You can use mg, fg, or weight, W for weight. Either one of those will work. Then they want us to figure out normal force is what is left over from mg minus the vertical component of force of pull. So mg minus 55 times sine of 20 degrees. So 177 newtons. Acceleration. Acceleration is caused by a net force equal to force of pull cosine of 20 minus mu mg minus mu times 177. That would be net force. So therefore, to find acceleration, I will divide that by 20. Gets me 0.64 meters per second squared. Next question, they want us to figure out how much work the boy will do with that 55 Newton force as he moves the dog sled system over 7 meters. That would be force, displacement, and cosine of the angle between them. Luckily, this is just 20 degrees. So 55 times 7, cosine of 20, 362 joules of energy. 362 joules of work completed by this young fella. In E, they tell us at some time TR, R for roll, the dog rolls off the sled, tired of these shenanigans, and they're asking us to draw the velocity versus time. Remember, the slope equals acceleration. So what happens when the dog rolls off? The force of pull is the same. Force of friction drops. So we have net force is now higher. Mass is lower. We have a much greater slope. And that completes this lovely question about a dog getting a sleigh ride from his owner. Thank you for watching.